Dear students of class 8th, welcome in today's lecture. I hope you all will listen to it carefully, and I'm sure that this will help you, obviously, provided if you all concentrate and try to understand what I'm going to teach you today in today's lecture. In the previous lecture, the topic under way is understanding quadrilaterals. In that lecture, we had tried to understand what quadrilaterals are, their types, and what polygons are, their types, like convex polygon, concave polygon, irregular polygon, and irregular polygon. Like different types of quadrilaterals, you are knowing what square is, what is the rectangle, or what are the properties of parallelogram, trapezium, and others. All of these are the quadrilaterals because they all have four sides, and rest all these different figures have different properties. You might be knowing all of those properties of these different quadrilaterals. But in today's topic, we will try to understand the angle sum property of a polygon. I have already told you about the polygon, that polygon is a figure. It is a geometrical figure rather, which is composed of more than two sides. Like there will be three sides, four sides, five sides, six sides, and so on. So if you have a figure where you see only three sides, a three-sided figure is called a triangle. Like this, I'm going to make a triangle over here. This is triangle, and this triangle has three sides. For example, this is vertex A, vertex B, and vertex C. So this is a triangle. This is a quadrilateral as well. Sorry, this is a polygon as well because it has more than two sides. In the same fashion, अगर हम आगे बढ़ेंगे, जब हम ये जानते हैं कि कोई ऐसी शक्ल, कोई ऐसी शेप जिसमें दो से ज़्यादा साइड्स मौजूद हों, जैसे three sides, four sides, five sides. Like I'm going to draw another shape over here. This is a shape. This shape has four sides. This is A, B, C, and D. One of the side is AB, another is BC, third one is DC, CD, and DA. So such a four-sided figure is called a polygon. Of course, the individual specific name to this is a quadrilateral as well, and this is a triangle specifically if we talk about it. But as a polygon, it has more than two sides. This figure has more than two sides. The first one, it has more than two sides. The second one has more than two sides. So any figure where you see more than two sides, that figure is called a polygon. So in the same manner we will move ahead. अगर हम और एक इसी तरह की एक फिगर यहाँ पे ड्रॉ करेंगे, जैसे this is a figure, one side, two side, this is the third side, fourth side, and this is the fifth side. And if I give the names and annex the names to its vertices, it will be like this. This is the A, B, C, D, and E. So this will become, this is a polygon because it has more than two sides. More than two sides, that means it has 1, 2, 3, 4, and 5. Like AB is the first side, BC second, CD third, DE fourth, and EA is the fifth one. So in such a figure, like the figure number third, we have five sides, 1, 2, 3, 4, 5. So this figure is a polygon, but the specific name to it is not a polygon. Generally you can call it a polygon, but it has five sides. On the basis of the number of the sides, there are different names given to different figures. Like on the basis of the number of the sides to the first figure, it is a triangle. On the basis of the number of sides to the second figure, it is a quadrilateral because it has four sides. And on the basis of the number of the sides to the third figure, it is a pentagon because it has five sides, 1, 2, 3, 4, 5. In the same manner, if you have any figure which has six sides like this, I will show you in another board. You keep on seeing this over here. This is the figure where you will see six sides, two sides, three, 4, 5, and 6. So this is A, B, C, D, and E, F. So AB is the one side, BC second, CD third, DE fourth, EF is the fifth, and FA is the sixth. So in such a figure, you are seeing 6 sides. So it is a hexagon, and it's the polygon as well, because in this figure there are more than 2 sides. Now it's very much clear to all of you that any figure where you see more than 2 sides, that is, there will be 3 sides, 4 sides, 5 sides, 6 sides, whatever it could be. You will have a different name for those figures on the basis of the number of the sides, but generally we always call such figures having more than 2 sides polygons. And the another question over here comes after this, when we are clear about the concept of the polygon, and then we will deal about the angles in these polygons. What will be the concept of the angles in these polygons? I will show you one by one. I will take the first polygon, that is a triangle. So definitely after having the concept of the triangle very much clear to you, because a triangle is a figure where you see 3 angles, 3 sides, and 3 vertices. 3 sides A, B, B, C, and CA. 3 vertices, that is vertex A, vertex B, and vertex C. But there are one more thing. There is one more thing, that is there are 3 sides. There are 3 angles as well: the angle A, angle B, and angle C. So what is the total sum of the angles, 3 angles of a triangle? This is a question for us today, where we are going to understand the angle sum property of different polygons. So in this concept, in this topic today, I will try to give you a simplest formula which will always help you to know about the angle sum property of a polygon. So the first polygon over here is what it is: a triangle in which you have 3 sides, you have 3 angles, and you have 3 vertices. So at this stage you have to do nothing with the vertices. You will take into consideration just 2 things, that is side AB, BC, and CA, that is 3 sides, and 3 angles, that is angle A, angle B, and angle C. Angle A, angle B, and angle C. Okay, just add another board and you will see over here, these are the 3 angles of this triangle. So in this triangle, where you have 3 angles A, B, and C, this is one angle, second angle, and third angle. So what is the total sum of all these angles? This is the question for us, how we can deal with these. The question is not actually इस सवाल की है कि angle A किस degree से, angle B किस degree से, angle C किस degree से. That is a different question that depends upon you, that depends upon the creator of a triangle, how much the degree he would give, or he would annex to any of the angle while drawing an angle. The question is, what is the total sum of all the 3 angles? Like this: angle A plus angle B plus angle C. What is the total sum of all these angles in a polygon? This is the question. This question is dealt always with the simplest formula. I will just quote that formula over here: angle sum property of a polygon. That formula can be used anywhere in all polygons, and to get what, that is angle sum of the total angles of a polygon, and that too the interior angles. I am not talking about the exterior angles. This is the question that we are dealing with. It is all about the interior angles of a polygon. So angle sum of interior angles of a polygon polygon. So it will, there is a formula, it is always equal to what, twice, sorry, I will drop it over here. It is always equal to n minus 2 into 180 degree. So 180 degree, you remember over here it's 180 degree. So this means, what is the n over here? N is the number of sides. You always remember this, number of sides. N is what? It is number of sides of a polygon. So we have a polygon that is triangle. It means that what is the angle sum? A is angle, S is sum of triangle. This is triangle. Angle sum of triangle it is equal to what? It is n minus 2 into 180 degree. N is number of sides. That is, in the triangle you are seeing how many sides? 3 sides. 3 minus 2 within the brackets into 180 degree. We will get surely over here the angle sum property, or the total sum of all the interior angles of a triangle over here is equal to 3 minus 2, that is 1, into 180 degree. That will come out as 180 degree into 1, that is 180 degrees. So it's now quite clear to all of you that the total sum of the angles, the interior angles of a polygon, that is over here, the first case of the polygon is triangle. In a triangle, the total sum of all the interior angles is equal to 180 degree. Now, individually, the three triangles will be of different magnitude. It may be at times any one of the angle will be 60, another will be 40, that is 100, and the third one surely will be then 80. So the breakage or the splitting of the total of the 180 degree depends upon the nature of the particular triangle. There are so many different types of the triangles. While dealing with those triangles, you will get the answer of that at that time when you deal with them. But at this stage, we are dealing with the total sum of the interior angles of a polygon. The first polygon is the triangle, and from the formula, that is n minus 2 into 180 degree, n is equal to the number of the sides, 3 minus 2 into 180 degree, that comes out to be 180 degree. It means that the total sum of the angles of a polygon triangle is always equal to 180 degree. In the same fashion, I will move just ahead and will try to understand you the second case of a polygon. That is, let us talk about the quadrilateral. Okay, this is the second polygon, because in quadrilateral we have more than two sides. That is, after 3 it will obviously be 4 sides in this figure. It means that this is the quadrilateral, this is the polygon as well. What will be the angle sum of this polygon? Let us try to understand. Formula is same. Angle sum of this quadrilateral, okay, it is equal to, or polygon, it is equal to n minus 2 into 180 degree. Same formula. It means that n is number of sides. How many sides in the second polygon? It is 4. 1, 2, 3, 4. You just see from the figure above, it is 4 minus 2 within the brackets into 180 degree. Okay, it will become 4 minus 2, that is 2 into 180 degree. So it's equal to 180 degree into 2, it will become 360 degrees. So it's very much clear that in this quadrilateral, or in the second polygon, the total sum of the interior angles, that means this angle, this angle, this angle, and this angle, the total sum of all these 4 angles will always be 360 degree. Now, in case of a square, one angle is always 90 degree. It means 4 angles will be 90, 90, 90, 90. It means 360 degree. The total sum, it means that the total sum of a polygon having 4 sides is always equal to 360 degree. The total sum of the interior angles of a polygon having 3 sides is always equal to 180 degree, as shown earlier in the first example. Let's move to the third example. For example, this is a polygon, the polygon number 3. It has how many sides? 5 sides. 1, 2, 3, 4, and 5. Okay, this is 5. This is the pentagon. This is angle A, vertex A, B, C, D, and A. It means that this is angle A, angle B, angle C, angle D, angle E. What is the total sum of all these 5 angles? It will be equal to angle sum property of this pentagon. Okay, it's always equal to, or the total sum of the angles, interior angles of this pentagon is always equal to n minus 2 into 180 degree. So n is equal to what? How many sides? 5 sides, minus 2 within the brackets into 180 degree. Okay, it will become 5 minus 2, it is 3 into 180 degree. So that will come out as 8 3s are 24, 2 carry, 3 1s are 3, 3 2 5. 540 degree will be the total sum of the interior angles of a pentagon. So let us move ahead and let us see the example number 4. That is what you can now easily get the sum of the interior angles. I'm just talking about the interior angles. Remember this, because for the exterior angles of a polygon there is a different rule. I will show you that rule in next lecture. In today's lecture, it's only about to know the total sum of the interior angles of a polygon and the formula which is associated with that. By the use of this simplest formula, you can get the total sum of the angles, interior angles of any polygon. What may be the number of the sides of that polygon? We have reached up to the number 5. Let's move to the number 6. If you have any polygon having how many sides? 6 sides, like this: 1, 2, 3, 4, 5, 6. So what will be the sum of the interior angles of this hexagon? Its specific name is hexagon and its general name is a polygon. That is again angle sum of this hexagon. Okay, it will be equal to same formula, n minus 2 into 180 degree. So this is n minus 6 minus 2 into, within the brackets, these 2 into 180. It is 4 into 180. What will be that? 720 degree. So 720 degree will be the angle sum, will be the total sum of the interior angles of this polygon. This is the hexagon. So in the same way, you can just get other things solved, like any other polygon having more than 6 sides, like 7 sides, 8 sides, 9 sides, 10 sides, whatever. You can easily use the formula by the use of this simple formula, which is n minus 2 into 180 degree. Okay, so this is very much easy to apply this formula to get the total number of what total number of total sum of the interior angles of any polygon. Using this formula, you will get it always. You can write this formula in this fashion as well, like n minus 2 outside bracket directly 180 degree without this cross. I'm using this cross to make you understand, because most of the students, I'm dealing with you from last 10 years. I'm knowing that why you feel the problem. Most of the students feel that there is no sign, there will not be anything else. That's why I'm using this cross. Otherwise, there is no need to use this cross or the sign of the multiplication. You can directly use this. It means that whatever will be the value over here, n minus 2, that value comes out to get multiplied with 180 degree. That will give the answer. So always use this formula, n minus 2 into 180 degree, to get the total sum of the interior angles of any polygon. In your chapter 3rd, exercise 3.1, you have so many questions. I think more than 4 or 5 questions dealing with the same formula. By the use of this simplest formula, you just open your textbook and see the exercise 3.1. You can easily make use of this formula and get the answers of those questions. I hope you will do that, and you will listen my this lecture, and definitely it will help you, inshallah. And tomorrow I will try to contact with you with the same media, with some other concept which will be possibly from the same topic, that is understanding quadrilaterals, because we have not completed it yet. And as soon as we will complete it, we will move to another topic. And by this way, I will try my level best to complete your syllabus, so that at least it will help you in your exams and later in the future as well. Till then, wish you all the best. Keep watching my videos and keep reaping the benefit, and keep acquainting yourself with the knowledge. God bless you all. Thank you. Thanks to all of you.